The de Havilland DH.98 Mosquito was a British twin-engine shoulder-winged multi-role combat aircraft. The crew of two, pilot and navigator, sat side by side. It served during and after the Second World War. It was one of few operational frontline aircraft of the era constructed almost entirely of wood and was nicknamed the Wooden Wonder. The Mosquito was also known affectionately as the Mossy to its crews. Originally conceived as an unarmed fast bomber, the Mosquito was adapted to roles including low to medium altitude daytime tactical bomber, high altitude night bomber, pathfinder, day or night fighter, fighter bomber, intruder, maritime strike aircraft, and fast photo reconnaissance aircraft. It was also used by the British Overseas Airways Corporation, BOAC, as a fast transport to carry small high-value cargoes to, and from, neutral countries, through enemy-controlled airspace. A single passenger could ride in the aircraft's bomb bay when it was adapted for the purpose. When Mosquito production began in 1941, it was one of the fastest operational aircraft in the world. Entering service in late 1941, the first Mosquito variant was an unarmed high-speed, high-altitude photo reconnaissance aircraft. Subsequent versions continued in this role throughout the war. The first MKB.4 bomber, serial No. W4064, entered service with No. 105 Squadron on November 15, 1941. From mid-1942 to mid-1943, Mosquito bombers flew high-speed, medium, or low-altitude daylight missions against factories, railways and other pinpoint targets in Germany and German-occupied Europe. From June 1943, Mosquito bombers were formed into the Light Night Strike Force and used as pathfinders for RAF Bomber Command heavy bomber raids. They were also used as nuisance bombers, often dropping blockbuster bombs 4,000 pounds, 1,812 kilograms, cookies in high altitude, high-speed raids that German night fighters were almost powerless to intercept. As a night fighter from mid-1942, the Mosquito intercepted Luftwaffe raids on Britain, notably those of Operation Steinbock in 1944. Starting in July 1942, Mosquito night fighter units raided Luftwaffe airfields. As part of 100 Group, it was flown as a night fighter and as an intruder supporting Bomber Command heavy bombers that reduced losses during 1944 and 1945. As a fighter bomber and strike aircraft in the 2nd Tactical Air Force, 2 TAF, and Coastal Command, the Mosquito often took part in special raids. One of the best known was Operation Jericho, an attack on Amiens prison in early 1944. Other 2 TAF operations included precision attacks against military intelligence, security, or police facilities, such as Gestapo headquarters. From 1943, Mosquitoes with RAF Coastal Command attacked Kriegsmarine U-boats, particularly in 1943 in the Bay of Biscay, where significant numbers were sunk or damaged, and intercepted transport ship concentrations. 2 TAF Mosquitoes also supported the British Army during the 1944 Normandy campaign. However, the Mosquito's unique construction, whilst conferring the defensive advantage of high speed, was also its Achilles heel on close air support or anti-shipping operations. The Mosquito's wooden airframe, fuselage, and surfaces made the aircraft more vulnerable to AA and cannon fire than its contemporary, the Bristol Beaufighter. This contributed to the longevity and esteem in which the latter was held, as a maritime strike aircraft and in the ground attack role, in the Mediterranean, Asia, and Pacific. The Mosquito flew with the Royal Air Force, RAF, and other air forces in the European, Mediterranean, and Italian theaters. The Mosquito was also operated by the RAF in the Southeast Asian Theatre and by the Royal Australian Air Force, RAF, based in the Halmahuras and Borneo during the Pacific War. During the 1950s, the RAF replaced the Mosquito with the jet-powered English Electric Canberra. Development. By the early mid-1930s, de Havilland had a reputation for innovative high-speed aircraft with the DH.88 Comet Racer. The later DH.91 Albatross airliner pioneered the composite wood construction used for the Mosquito. The 22-passenger Albatross could cruise at 210 miles per hour, 340 km per hour, at 11,000 feet, 3,400 m, 100 miles per hour, 160 km per hour, faster than the Handley Page H.P.42 and other biplanes it was replacing. The wooden monocoque construction not only saved weight and compensated for the low power of the de Havilland Gypsy 12 engines used by this aircraft, but simplified production and reduced construction time. Air Ministry bomber requirements and concepts. On September 8, 1936, the British Air Ministry issued Specification P.13/36, which called for a twin-engine medium bomber capable of carrying a bomb load of 3,000 pounds, 1,400 kilograms, for 3,000 miles, 4,800 kilometers, with a maximum speed of 275 miles per hour, 443 kilometers per hour, at 15,000 feet, 4,600 m, a maximum bomb load of 8,000 pounds, 3,600 kilograms, that could be carried over shorter ranges was also specified. Aviation firms entered heavy designs with new high-powered engines and multiple defensive turrets, leading to the production of the Avro Manchester and Handley Page Halifax. In May 1937, as a comparison to P.13/36, George Volkert, the chief designer of Handley Page, put forward the concept of a fast unarmed bomber. In 20 pages, Volkert planned an aerodynamically clean medium bomber to carry 3,000 pounds, 1,400 kilograms, of bombs at a cruising speed of 300 miles per hour, 480 kilometers per hour. There was support in the RAF and Air Ministry. Captain R. N. Liptrot, Research Director Aircraft 3, RDA-3, appraised Volkert's design, calculating that its top speed would exceed that of the new Supermarine Spitfire. There were, however, counter-arguments that, although such a design had merit, it would not necessarily be faster than enemy fighters for long. The ministry was also considering using non-strategic materials for aircraft production, which, in 1938, had led to Specification B.9/38 and the Armstrong-Whitworth Albemarle medium bomber, largely constructed from spruce and plywood attached to a steel tube frame. The idea of a small, fast bomber gained support at a much earlier stage than is sometimes acknowledged, though it was likely that the Air Ministry envisaged it using light alloy components. Inception of the de Havilland fast bomber. Based on his experience with the Albatross, Geoffrey de Havilland believed that a bomber with a good aerodynamic design and smooth, minimal skin area, would exceed the P.13/36 specification. Furthermore, adapting the Albatross principles could save time. In April 1938, performance estimates were produced for a twin Rolls-Royce Merlin-powered DH.91, with the Bristol Hercules, radial engine, and Napier Sabre, H engine, as alternatives. On July 7, 1938, Geoffrey de Havilland wrote to Air Marshal Wilfred Freeman, the Air Council's member for research and development, discussing the specification and arguing that in war there would be shortages of aluminium and steel but supplies of wood-based products were adequate. Although inferior in tension, the strength-to-weight ratio of wood is equal to or better than light alloys or steel, hence this approach was feasible. A follow-up letter to Freeman on July 27 said that the P.13/36 specification could not be met by a twin Merlin-powered aircraft and either the top speed or load capacity would be compromised, depending on which was paramount. For example, a larger, slower, turret-armed aircraft would have a range of 1,500 miles, 2,400 kilometers, carrying a 4,000 pound, 1,800 kilograms, bomb load, with a maximum of 260 miles per hour, 420 kilometers per hour, at 19,000 feet, 5,800 m, and a cruising speed of 230 miles per hour, 370 kilometers per hour, at 18,000 feet, 5,500 m. De Havilland believed that a compromise, including eliminating surplus equipment, would improve matters. On October 4, 1938, de Havilland projected the performance of another design based on the Albatross, powered by two Merlin XS, with a 3-man crew and 6 or 8 forward-firing guns, plus 1 or 2 manually operated guns and a tail turret. Based on a total loaded weight of 19,000 pounds, 8,600 kilograms, it would have a top speed of 300 miles per hour, 480 kilometers per hour, and cruising speed of 268 miles per hour, 431 kilometers per hour, at 22,500 feet, 6,900 m. Still believing this could be improved, and after examining more concepts based on the Albatross and the new all-metal DH.95 Flamingo, de Havilland settled on designing a new aircraft that would be aerodynamically clean, wooden, and powered by the Merlin, which offered substantial future development. The new design would be faster than foreseeable enemy fighter aircraft, and could dispense with a defensive armament, which would slow it and make interception or losses to anti-aircraft guns more likely. Instead, high speed and good maneuverability would make it easier to evade fighters and ground fire. The lack of turrets simplified production and reduced production time, with the delivery rate far in advance of competing designs. Without armament, the crew could be reduced to a pilot and navigator. Whereas contemporary RAF design philosophy favored well-armed heavy bombers, this mode of design was more akin to the German philosophy of the Schnellbomber. At a meeting in early October 1938 with Geoffrey de Havilland and Charles Walker, de Havilland's chief engineer, the Air Ministry showed little interest, and instead asked de Havilland to build wings for other bombers as a subcontractor. By September 1939 de Havilland had produced preliminary estimates for single and twin-engined variations of light bomber designs using different engines, speculating on the effects of defensive armament on their designs. One design, completed on September 6, was for an aircraft powered by a single 2,000 HP, 1,500 kilowatts, Napier Sabre, with a wingspan of 47 foot, 14 m, and capable of carrying a 1,000 pound, 450 kilograms, bomb load 1,500 miles, 2,400 kilometers. On September 20, in another letter to Wilfred Freeman, de Havilland wrote, "We believe that we could produce a twin-engine bomber which would have a performance so outstanding that little defensive equipment would be needed." By October 4 work had progressed to a twin-engine light bomber with a wingspan of 51 feet 3 in, 15.62 m, and powered by Merlin or Griffin engines, the Merlin favored due to availability. On October 7, 1939, a month into the war, the nucleus of a design team under Eric Bishop moved to the security and secrecy of Salisbury Hall to work on what was later known as the DH.98. For more versatility, Bishop made provision for 4 20mm cannon in the forward half of the bomb bay, under the cockpit, firing via blast tubes and troughs under the fuselage. The DH.98 was too radical for the ministry, which wanted a heavily armed, multi-role aircraft, combining medium bomber, reconnaissance, and general-purpose roles, as well as capable of carrying torpedoes. With outbreak of war, the ministry became more receptive, but still skeptical about an unarmed bomber. It thought the Germans would produce fighters faster than expected. It suggested 2 forward and 2 rear-firing machine guns for defense. The ministry also opposed a 2-man bomber, wanting at least a third crewman to reduce the work of the others on long flights. The Air Council added further requirements, such as remotely controlled guns, a top speed of 275 miles per hour, 443 kilometers per hour, at 15,000 feet, 4,600 m, on 2/3 engine power, and a range of 3,000 miles, 4,800 kilometers, with a 4,000 pounds, 1,800 kilograms, bomb load. To appease the ministry, de Havilland built mock UPS with a gun turret just aft of the cockpit, but, apart from this compromise, de Havilland made no changes. On November 12, at a meeting considering fast bomber ideas put forward by de Havilland, Blackburn, and Bristol, Air Marshal Freeman directed de Havilland to produce a fast aircraft, powered initially by Merlin engines, with options of using progressively more powerful engines, including the Rolls-Royce Griffin and the Napier Sabre. Although estimates were presented for a slightly larger Griffin-powered aircraft, armed with a 4-gun tail turret, Freeman got the requirement for defensive weapons dropped, and a draft requirement was raised calling for a high-speed light reconnaissance bomber capable of 400 miles per hour, 640 kilometers per hour, at 18,000 feet, 5,500 m. On December 12, the Vice Chief of the Air Staff, Director General of Research and Development, and the Air Officer Commanding-in-Chief, AOC, of RAF Bomber Command met to finalize the design and decide how to fit it in the RAF's aims. The AOC would not accept an unarmed bomber, but insisted on its suitability for reconnaissance missions with F-8 or F-24 cameras. After company representatives, the Ministry, and the RAF's operational commands examined a full-scale mock-up at Hatfield on December 29, 1939, the project received backing. This was confirmed on January 1, 1940, when Freeman chaired a meeting with Geoffrey de Havilland, John Buchanan, Deputy of Aircraft Production, and John Connolly, Buchanan's Chief of Staff. De Havilland claimed the DH.98 was the fastest bomber in the world. It must be useful. Freeman supported it for RAF service, ordering a single prototype for an unarmed bomber to specification B.1/40/DH, which called for a light bomber/reconnaissance aircraft powered by two 1,280 HP, 950 kilowatts, Rolls-Royce RM3SM, an early designation for the Merlin 21, with ducted radiators, capable of carrying a 1,000 pound, 450 kilograms, bomb load. The aircraft was to have a speed of 397 miles per hour, 639 kilometers per hour, at 23,700 feet, 7,200 m, and a cruising speed of 327 miles per hour, 526 kilometers per hour, at 26,600 feet, 8,100 m, with a range of 1,480 miles, 2,380 kilometers, at 24,900 feet, 7,600 m, on full tanks. Maximum service ceiling was to be 32,100 feet, 9,800 m. On March 1, 1940, Air Marshal Roderick Hill issued a contract under specification B.1/40, for 50 bomber reconnaissance variants of the DH.98. This contract included the prototype, which was given the factory serial E0234. In May 1940, specification F.21/40 was issued, calling for a long-range fighter armed with 420 mm cannon and 4.303 machine guns in the nose, after which de Havilland were authorized to build a prototype of a fighter version of the DH.98. It was decided after debate that this prototype, given the military serial number W4052, would carry airborne interception, AI, Mk.4 equipment as a day and night fighter. By June 1940, the DH.98 had been named Mosquito. Having the fighter variant kept the Mosquito project alive, as there was still criticism within the government and Air Ministry of the usefulness of an unarmed bomber, even after the prototype had shown its capabilities. Project Mosquito. With design of the DH.98 started, mock UPS were built, the most detailed at Salisbury Hall, where E0234 was later constructed. Initially, the concept was for the crew to be enclosed in the fuselage behind a transparent nose, similar to the Bristol Blenheim or Heinkel He-111H, but this was quickly altered to a more solid nose with a conventional canopy. The construction of the prototype began in March 1940, but work was cancelled again after the Battle of Dunkirk, when Lord Beaverbrook, as Minister of Aircraft Production, decided there was no production capacity for aircraft like the DH.98, which was not expected to be in service until early 1942. Beaverbrook told Air Vice Marshal Freeman that work on the project should stop, but he did not issue a specific instruction, and Freeman ignored the request. In June 1940, however, Lord Beaverbrook and the Air Staff ordered that production should focus on 5 existing types, namely the Supermarine Spitfire, Hawker Hurricane Fighter, Vickers Wellington, Armstrong Whitworth Whitley, and Bristol Blenheim bombers. Work on the DH.98 prototype stopped. Apparently the project shut down when the design team were denied materials for the prototype. The Mosquito was only reinstated as a priority in July 1940, after de Havilland's general manager L.C.L. Murray promised Lord Beaverbrook 50 mosquitoes by December 1941. This was only after Beaverbrook was satisfied that mosquito production would not hinder de Havilland's primary work of producing Tiger Moth and Airspeed Oxford trainers, repairing Hurricanes, and manufacturing Merlin engines under license. In promising Beaverbrook such a number by the end of 1941, de Havilland was taking a gamble, because it was unlikely that they could be built in such a limited time. As it transpired, only 20 aircraft were built in 1941, but the other 30 were delivered by mid-March 1942. During the Battle of Britain, interruptions to production due to air raid warnings caused nearly a third of de Havilland's factory time to be lost. Nevertheless, work on the prototype went ahead quickly at Salisbury Hall since E0234 was completed by November 1940. In the aftermath of the Battle of Britain, the original order was changed to 20 bomber variants and 30 fighters. It was still uncertain whether the fighter version should have dual or single controls, or should carry a turret, so 3 prototypes were built, W4052, W4053, and W4073. The second and third, both turret-armed, were later disarmed, to become the prototypes for the T.3 trainer. This caused some delays since half-built wing components had to be strengthened for the required higher combat loading. The nose sections also had to be changed from a design with a clear perspex bombarder's position, to one with a solid nose housing 4.303 machine guns and their ammunition. Prototypes and test flights. On November 3, 1940, the aircraft, painted in prototype yellow and still coded E0234, was disassembled and transported by road to Hatfield, and placed in a small blast-proof assembly building. 2 Merlin 21 2-speed single-stage supercharged engines were installed, driving 3-bladed de Havilland Hydromatic constant speed, controllable pitch propellers. Successful engine runs were made on November 19. On November 24, successful taxiing trials were carried out by Geoffrey de Havilland Jr., who was the company's chief test pilot. Then on November 25, the prototype made its first flight, piloted by Geoffrey de Havilland Jr., accompanied by John E. Walker, the chief engine installation designer. For this maiden flight, E0234, weighing 14,150 pounds, 6,420 kilograms, took off from the grass airstrip at the Hatfield site. The takeoff was reported as straightforward and easy, and the undercarriage was not retracted until a considerable height was attained. The aircraft reached 220 miles per hour, 350 kilometers per hour, with the only problem being the undercarriage doors, which were operated by bungee cords attached to the main undercarriage legs that remained open by some 12 inches, 300 millimeters, at that speed. This problem persisted for some time. The left wing of E0234 also had a tendency to drag to port slightly, so a rigging adjustment, i.e., a slight change in the angle of the wing, was carried out before further flights. On December 5, 1940, the prototype, now with its military serial number W4050, experienced tail buffeting at speeds between 240 miles per hour, 390 kilometers per hour, and 255 miles per hour, 410 kilometers per hour. The pilot noticed this most in the control column, with handling becoming more difficult. During testing on December 10, wool tufts were attached to suspect areas to investigate the direction of airflow. The conclusion was that the airflow separating from the rear section of the inner engine nacelles was disturbed, leading to a localized stall, and the disturbed airflow was striking the tailplane, causing buffeting. In an attempt to smooth the airflow and deflect it from forcefully striking the tailplane, non-retractable slots fitted to the inner engine nacelles and to the leading edge of the tailplane were experimented with. These slots, and wing root fairings fitted to the forward fuselage and leading edge of the radiator intakes, stopped some of the vibration experienced but did not cure the tailplane buffeting. In February 1941, buffeting was eliminated by incorporating triangular fillets on the trailing edge of the wings and lengthening the nacelles, the trailing edge of which curved up to fare into the fillet some 10 in, 250 mm, behind the wing's trailing edge. This meant the flaps had to be divided into inboard and outboard sections. With the buffeting problems largely resolved, John Cunningham flew W4050 on February 9, 1941. He was greatly impressed by the lightness of the controls and generally pleasant handling characteristics. Cunningham concluded that when the type was fitted with AI equipment, it might completely replace the Bristol Beaufighter, in the night fighter role. During its trials on January 16, 1941, W4050 outpaced a Spitfire at 6,000 feet, 1,800 m. The original estimates were that as the Mosquito prototype had twice the surface area and over twice the weight of the Spitfire Mk2, but also with twice its power, the Mosquito would end up being 20 miles per hour, 32 kilometers per hour, faster. Over the next few months, W4050 surpassed this estimate, easily beating the Spitfire Mk2 in testing at RAF Boscombe Down in February 1941, reaching a top speed of 392 miles per hour, 631 kilometers per hour, at 22,000 feet, 6,700 m, altitude, compared to a top speed of 360 miles per hour, 580 kilometers per hour, at 19,500 feet, 5,900 m, for the Spitfire. On February 19, official trials began at the Aeroplane and Armament Experimental Establishment, ANAE, based at Boscombe Down, although de Havilland's representative was surprised by a delay in starting the tests. On February 24, as W4050 taxied across the rough airfield, the tail wheel jammed, leading to the fuselage fracturing. Repairs were made by early March, using part of the fuselage of the photo reconnaissance prototype W4051. In spite of this setback, the initial handling report 767 issued by the ANAE stated the aeroplane is pleasant to fly. Aileron control light and effective. The maximum speed reached was 388 miles per hour, 624 kilometers per hour, at 22,000 feet, 6,700 m, with an estimated maximum ceiling of 33,900 feet, 10,300 m, and a maximum rate of climb of 2,880 feet/min, 880 m/min, at 11,400 feet, 3,500 m. W4050 continued to be used for various test programs, essentially as the experimental workhorse for the Mosquito family. In late October 1941, it returned to the factory to be fitted with Merlin 61s, the first production Merlins fitted with a two-speed, two-stage supercharger. The first flight with the new engines was on June 20, 1942. W4050 recorded a maximum speed of 428 miles per hour, 689 kilometers per hour, at 28,500 feet, 8,700 m, fitted with straight-through air intakes with snow guards, engines in FS gear, and 437 miles per hour, 703 kilometers per hour, at 29,200 feet, 8,900 m, without snow guards. In October 1942, in connection with development work on the NFMK-15, W4050 was fitted with extended wingtips increasing the span to 59 feet 2 in, 18.03 m, first flying in this configuration on December 8. Finally, fitted with high-altitude rated two-stage, two-speed Merlin 77s, it reached 439 miles per hour, 707 kilometers per hour, in December 1943. Soon after these flights, W4050 was grounded and scheduled to be scrapped, but instead served as an instructional airframe at Hatfield. In September 1958, W4050 was returned to the Salisbury Hall hangar where it was built, restored to its original configuration, and became one of the primary exhibits of the de Havilland Aircraft Heritage Center. W4051, which was designed from the outset to be the prototype for the photo reconnaissance versions of the Mosquito, was slated to make its first flight in early 1941. However, the fuselage fracture in W4050 meant that W4051's fuselage was used as a replacement. W4051 was then rebuilt using a production standard fuselage and first flew on June 10, 1941. This prototype continued to use the short engine nacelles, single-piece trailing edge flaps and the 19 feet 5.5 in, 5.931 m, number 1 tailplane used by W4050, but had production standard 54 feet 2 in, 16.51 m, wings and, thus configured, became the only Mosquito prototype to fly operationally. Construction of the fighter prototype, W4052 was also carried out at the secret Salisbury Hall facility. This differed from the bomber brethren in a number of ways. It was powered by 1,460 HP, 1,090 kilowatts, Merlin 21s, had an altered canopy structure with a flat bulletproof windscreen, a solid nose-mounted 4.303 in, 7.7 mm, Browning machine guns and their ammunition boxes, accessed by a single large, sideways hinged panel, 420 mm, 0.79 in, Hispano Mk2 cannon were housed in a compartment under the cockpit floor, with the breeches projecting into the bomb bay, and the automatic bomb bay. Doors were replaced by manually operated bay doors, which incorporated cartridge ejector chutes. In accordance with its role as a day/night fighter prototype, W4052 was equipped with AIMK.4 equipment, complete with an arrowhead-shaped transmission aerial mounted between the central Brownings, and receiving aerials through each outer wingtip, and it was painted in overall black RDM to a special night finish. It was also the first prototype constructed with the extended engine nacelles. W4052 was later tested with other modifications including bomb racks, drop tanks, barrage balloon cable cutters in the leading edge of the wings, Hamilton air screws and braking propellers, as well as drooping aileron systems that enabled steep approaches, and a larger rudder tab. The prototype continued to serve as a test machine until it was scrapped on January 28, 1946. 4055 flew the first operational Mosquito flight on September 17, 1941. During flight testing, the Mosquito prototypes were modified to test a number of experimental configurations. W4050 was fitted with a turret behind the cockpit for drag tests, after which the idea was abandoned in July 1941. W4052 had the first version of the Youngman frill air brake fitted to the fighter prototype. The frill was mounted around the fuselage behind the wing and was opened by bellows and venturi effect to provide rapid deceleration during interceptions, and was tested between January-August 1942, but was also abandoned when it was discovered that lowering the undercarriage had the same effect with less buffeting. Production plans and American interest. The Air Ministry authorized mass production plans on June 21, 1941, by which time the Mosquito had become one of the world's fastest operational aircraft. They ordered 19 photo reconnaissance (PR) models and 176 fighters. A further 50 were unspecified. In July 1941, it was confirmed these would be unarmed fast bombers. By the end of January 1942, contracts had been awarded for 1,378 Mosquitoes of all variants, including 20 T.3 trainers and 334 FB.VI bombers. Another 400 were to be built by de Havilland, Canada. On April 20, 1941, W4050 was demonstrated to Lord Beaverbrook, the Minister of Aircraft Production. The Mosquito made a series of flights, including one rolling climb on one engine. Also present were U.S. General Henry H. Arnold and his aide Major Elwood Quesada, who wrote, "I recall the first time I saw the Mosquito as being impressed by its performance, which we were aware of. We were impressed by the appearance of the airplane that looks fast usually is fast, and the Mosquito was, by the standards of the time, an extremely well streamlined airplane, and it was highly regarded, highly respected." The trials set up future production plans between Britain, Australia, and Canada. 6 days later Arnold returned to America with a full set of manufacturer's drawings. As a result of his report, 5 companies, Beech, Curtiss-Wright, Fairchild, Fleetwings, and Hughes, were asked to evaluate the de Havilland data. The report by Beech Aircraft summed up the general view: it appears as though this airplane has sacrificed serviceability, structural strength, ease of construction and flying characteristics in an attempt to use construction material which is not suitable for the manufacture of efficient airplanes. The Americans did not pursue the proposal for licensed production, the consensus arguing that the Lockheed P-38 Lightning could fulfill the same duties. However, Arnold urged the United States Army Air Forces to evaluate the design even if they would not adopt it. On December 12, 1941, after the attack on Pearl Harbor, the USAF requested one airframe for this purpose. Design and manufacture. Overview. While timber construction was considered outmoded by some, de Havilland claimed that their successes with techniques used for the DH-91 Albatross could lead to a fast light bomber using monocoque sandwich shell construction. Arguments in favor of this included speed of prototyping, rapid development, minimization of jig building time, and employment of a separate category of workforce. At the same time, they had to fight conservative Air Ministry views on defensive armament. Guns and gun turrets would spoil the streamlining, losing speed and maneuverability. The ply-ball supply monocoque fuselage and one-piece wings with doped fabric covering gave smooth aerodynamic performance and low weight, combined with strength and stiffness. Whilst submitting these arguments, Geoffrey de Havilland funded his private venture until the 11th hour. It was a success beyond all expectations. The initial bomber and photo reconnaissance versions were extremely fast, whilst the armament of subsequent variants might be regarded as primarily offensive. The most produced variant, designated the FB-Mk6, Fighter Bomber Mark VI, was powered by 2 Merlin Mk23 or Mk25 engines driving 3-bladed de Havilland hydromatic propellers. The typical fixed armament for an FB-Mk6 was 4 Browning .303 machine guns and 4 20mm Hispano cannon, while the offensive load consisted of up to 2,000 pounds, 910 kilograms, of bombs, or 8 RP-3 unguided rockets. Performance. The design was noted for light and effecty.
Please subscribe and thanks for watching.